The Applications SL course is mostly similar to the existing Studies SL. However, the entry point is a little higher. Topics such as linear equations, formulae and their rearrangement, perimeter and area, Pythagoras, and coordinate geometry were previously within Studies SL, but they are now assumed knowledge. We would also recommend that students preparing for this course study some more transformation geometry than previous. This will help with modeling in understanding and explaining the effect of a particular parameter. All these things are covered in the background knowledge material included online with the Core Topics SL. However, be warned that spending class time on this content may make it very difficult to finish the course. Some new topics for the Applications SL course include 3D coordinate geometry, which will certainly be a challenge for students struggling with 3D spatial awareness, sampling methods, loans and annuities, which are further applications of the TVM solver on their calculator, and the modeling cycle, which adds some more formal discussion about modeling, assumptions, and predictions. Most of the functions work is quite similar to the existing Studies SL course, as is the differential calculus. However, there is now some integral calculus. We believe the focus here will be on positive functions and the area under a curve, and for this application, we think integration is actually more intuitive for weaker students than differentiation is. We will open with some numerical methods for the area under a curve, which is actually the history of integration and so ties in well with IB thinking. The Riemann Integral is a scary title, but all this means is a direct integral which gives us the area under a curve. It gives us some integral notation. The fundamental theorem of calculus gives us a link to the differentiation we have already studied. It motivates us to anti-differentiate. We generalize from examples to give basic rules for integration, and we then tie it all together by returning to definite integrals and the area under a curve. So overall, we think integration is not too frightening. However, when we get towards the end of the course, we hit a big chapter on hypothesis testing. In the existing Studies SL course, we have the chi-squared test for independence. However, in addition here, we have the t-test, the two-sample t-test, and the chi-squared goodness of fit test. Understanding the mathematics behind the tests is difficult without heavy algebra, so instead we need to focus on why we are doing them. Students need to understand the purpose for each of the tests in order to select the correct one to use. The t-test may also be a challenge because its definition requires the standard deviation of a sample, whereas in the work on one-variable statistics, they study the standard deviation of a population. Our recommendation is therefore to at least discuss in class, while doing the one-variable statistics, that two forms of standard deviation exist, and to distinguish between them on the calculator display. Finally, we meet Voronoi diagrams. We think the elegance of these may be lost as their abstract beauty is rather more pure mathematical thought. However, we think the focus in this course will very much be interpreting Voronoi diagrams, adding an extra site, finding the equation of an edge, or finding the largest available circle within the diagrams. The exam questions for this topic should thus be relatively predictable. Overall, there are 12 chapters in the Core Topics SL book and 17 chapters in the Analysis SL book. By the end of the first year, we feel that at minimum, you need to get to the end of Chapter 5 in the second book.